morning, everyone. Today, I am going to talk about a very important topic for modern organizations. It's business analytics. In simple words, business analytics is about using the data to make better decisions. Every company today is surrounded by data like sales data, customer data, website data, social media, etc. The companies that know how to use this data properly get a big competitive advantage. They can work more efficiently, understand their customer better, and run their operations in a smarter way. In this class, we will going to learn the entire concept of business analytics. And then we will see its principles, the different roles in analytical teams, and the analytic life cycle. And finally, we are going to see different types of analytics. Let us start with the basic question. What exactly is business analytics? Business analytics is a scientific way of taking a data and turning it into a useful insights for decision making. It sits between raw data and business strategy. On one side, you have a raw numbers. On the other side, you have a business decisions. It's called as a business analytics. In general, BA or business analytics is a bridge between connecting those two. With analytics, organizations can understand past trends, predict what might happen in the future, and also improve their process in a systematic way. Instead of saying, I feel this will work, managers can say the data suggests this will work, and here is the evidence. To understand the business analytics in depth or better, think of its four simple building block. One is an data, second tools, third techniques, and decision. First, we have a data. Data, this is our raw material or raw data. It could be sales transaction, customer feedback, website clicks, sensor readings, or even HR records, or any kind of transactions which belongs to that particular corporation. Without data, there is nothing to analyze. So data can be acted as a main pillar for any kind of an business analytical project. Second, we have tools. These are the software platforms we use. Most commonly used tools are MS Excel, SQL structured query language, or even Python programming language, or R programming language, business intelligence tools, and cloud systems. These tools help us store data, clean data, process it, and visualization. Third, we have techniques. These are the analytical methods such as statistical analysis, forecasting, machine learning, and data visualization. These techniques helps us find patterns and relationships in the data. Finally, we have decisions. This is a real goal. All the analysis must support some decisions. How much to produce, which customers to target, how to how to price a product, where to open a new store. So you can remember this simple flow. Data goes into tools, we apply the techniques, and we get better decisions. Again, now we will going to take a look of core principles of business analytics. First, data-driven decision making. Second, value creation. Third, transparency. Fourth, iterative process. Finally, ethical use of data. First, data-driven decision making. This means we try to replace a guesswork and gut feeling with the evidence from data. For instance, Instead of assuming a market campaign was successful, we look at the numbers and see if the sales actually improved or not. Iterative process. Analytics is not a one-time activity. We do not build one model and forget it. We refine our models and update our reports and improve our approach as we get a new data and feedback from the customers. Value creation. Analytics is not done just for fun. Even every analysis should tie back to a business objective, maybe increasing revenue, reducing cost, improving customer satisfaction, or lowering the risk. Finally, we have a ethical use of data. We have to respect the privacy, avoid discrimination, and follow regulations of the government when we use the data. If we misuse the data, the organization can lose trust and face legal problems from the government. Transparency. We should be clear about where our data came from, what methods we used, and what assumptions we made to build a model. When people understand this process, they are more likely to trust and use the results. Now we will move to the topic called the analytics team. Analytics in general is not done by only one person alone. It's a team effort with different roles. Let me go through the key roles. One is an business analyst, second data analyst, third data scientist, fourth data engineers, finally business managers. Business analyst, middle between business and data teams. They talk to managers, understand the problems, and convert those into a clear analytical requirements. Data analysts, on the other hand, they are storytellers or the storytellers of the data, available data. They claim, they visualize, they report, and help managers understand what is happening. Third, we are having the data scientist role. They are deeper modeling. They use statistics and programming to build predictive and machine learning models. They discover hidden patterns from the data and forecast outcomes for the future. Next, business managers. They are decision makers who use the insights. Their roles is to translate insight into actions like changing strategy, adjusting budgets, or launching initiatives. In a good analytical teams, all these roles collaborate closely so that technical work is always aligned with business goals. Students often ask, what's the difference between analytics and data science? First, we have to look into analytics. Analytics mainly focuses on understanding what has already happened and why. Using a historical and current data, it answers questions like what were our sales last month, or why did sales increases in one region and decreases in another. So that's an analytical question. On the other hand, we are having the data science. Data science goes a step further. It combines analytics with advanced programming, machine learning, and big data technologies. Data science answers the questions like which product will sell the most next month, or which customers are likely to leave in the next 90 days. So, data science is equivalent to analytics plus advanced programming plus predictive modeling and big data. Both are important. Analytics is for understanding and reporting. Data science is for predicting and automating decisions. Now we will let's look at how an analytical project typically runs from start to finish. The whole concept is called as the data analytical or analytics life cycle. The core idea is instead of a random analysis, follow a structured process that starts with a business problem and ends with a deployed solution that is continuously improved. In this analytical life cycle, we are having the phases of discovery, preparing a data, planning a model, building a model, validating a model, deployment of the model, and iteration phase. First, discovery. Define the business problem and also set goals. This is called as an discovery. Second, we are having the data preparation. It includes the process like collecting the data, cleaning the data, and integrate the data from internal like ERP, CRM, or HR, or any kind of an external sources like market, social, or any kind of an medias. Third, we have to plan a model. For that, we have to use techniques like regression, classification, clustering, time series, etc. Fourth, model building. Build a statistical or ML model based on the requirement. Fifth, validation. Check the model performance with training, testing, cross validation, accuracy, precision, and recall. Finally, we are having the deployment. Once the model is ready, sixth, deployment. Once the model is ready, deploy through dashboards, automated reports, or application integration. Finally, iteration. After deployment, monitor and update models as new data arrives and also condition changes. There will be types of analytics. We are having the classifications like descriptive, diagnostic, predictive, and prescriptive. Descriptive analytics, what happened? For example, monthly sales, web traffic, number of complaints, the current and past status. These are all the examples of descriptive analytics. Second, diagnostic analytics. Why did it happen? Dig into reasons behind the changes. For instance, was sales drop due to price increase, new competitor, or service issue? Third, predictive analytics. What is likely to happen? Like in this predictive analytics, we use forecasting, regression, or machine learning to estimate future demand, revenue, or churn. Finally, we are having the prescriptive analytics. What should we do? Recommend actions using an optimization and simulation models, optimal price, marketing mix, or inventory levels. A retail company, a retail example, start with sales report called descriptive, analyze sales drivers, diagnostic, forecast demands, predictive, and then optimize inventory called prescriptive. Defining a business problem. Before touching the data, always clearly define the business problem. If you don't know the question you are answering, you might waste time with the wrong data and models. First, identify objectives, understand the big business goal. Second, define KPIs. Set how you will measure success, like churn rate, profit margin, etc. Third, translate the business questions to a clear analytical problem. For example, reduce customer churn. Predict with customers are likely to leave in the next 90 days and why. Fourth, set success criteria. Decide how you will measure results like model accuracy or actual churn reduction. Never start analyzing without understanding the business question. Data collection and preparation. Data collection. Organizations gather from internal like ERP, CRM, HRM, HR, and external data like social surveys or social media marketing data. These techniques include surveys, APIs, web scraping, transaction logs. The main challenges are accuracy, access, privacy, and cost. Data preparation take the raw data and make it usable. This is 60 to 80% of total effort. Uh, in this data preparation phase, we are going to use some of the process like data cleaning, integration, transformation, or reduction. So data cleaning, missing data, duplicates, and incorrect data, we have to solve this kind of a problem. Integration, we are combined from many sources or tables. Transformation process including normalize, aggregate, encode variables during the process. Finally, reduction, we have to remove irrelevant or inconsistent or redundant features from the data set. A clean, well-structured data set is needed for good modeling. From hypothesis to deployment, start with hypothesis. For example, H0 discounts don't increase sales. H1 discounts do. Use data or testing to support or reject the hypothesis. Modeling, use the right method for the problem. Like some problems it required regression and some other problems it required classification or clustering or forecasting also. Validation, check how well the model performs by means of accuracy, precision, recall, RMSE or R squared value. Interpretation, turn technical results into business language and visuals linked to KPIs. Deployment and iteration, implement model into dashboards or reports or engines or monitor and update as needed. In general, or in a conclusion, business analytics as a process helps organization predict, optimize, and take action with confidence. Thank you all.